today's episode, we will not only limit our discussion to safety in our homes, we also discuss about safety in our community. I think earlier last year, there was this very sad, this horrific picture that I saw that actually broke my heart. It did not only break my heart, though, it also shattered my heart into pieces. I don't know if na heart, I mean na hurt, I mean na hurt, I don't know, but it shattered my heart into pieces. What was the video about? A very small boy got electrocuted with or to or on the transformer. I couldn't look at the picture twice. A young boy who knows nothing, the innocent boy who knows nothing about how the transformer got there, who knows nothing about, who is not an elderly person to advise the community to put a guard to prevent young children from entering that what can I call it, within that space of where that transformer was. And this boy, as a child, was playing around and got to where the transformer is, and you maybe wanted to pick something and he got electrocuted. And you know, when they say electrocution no be say it go shock you, it go come on your hand, it will hold you till it dries you up. And that was how the innocent boy died. And imagine a boy who has a bright future got electrocuted and died in the course of failure in the part of those that brought the transformer to that community. Even if your government no provide them for you, you are supposed to provide it yourself. And that is what we'll be discussing today on this platform. We're discussing about electrical safety in our homes, and in our community at large. Right about now, we are about to stick that the event. Sorry, I'm not that good with English, so you manage my grammar like that. But our advice, you get a bulletproof so that it will be safe. This is about safety, so that when I blow a grammar and doesn't all go well with you, you have something to prevent yourself from getting affected by my grammatical discomfort. And you might hear some background noise. So today is Sunday, but your lawyer boy is on site trying to make sure things work well. So I apologize in advance when you get that kind of background noise. We are starting the event automatically now. Thank you for your presence. Our host is on ground. Mrs. Marian is on ground to educate us today. Mr. Engineer Dansaki, Mr. Gabriel, Mr. Bolaji, and Mr. Emmanuel. I know we have lots of things to learn from my professionals today. My name is walieyullah, aka Safety Moment with walieyullah, and we shall be discussing about electrical safety. We'll be giving a background understanding of this discussion of today, as like I have said a few minutes ago, about why we need to discuss about electricity. Electricity is what is common to us. It's one of those common amenities, basic amenities that we use in our world today. Aside water, what again is common? Oxygen. Yes, I think the next thing should be electricity. So, but of electricity now poses more hazard to us, more risk, and a lot of people have died as a result of exposure to electrical hazards. And that is what we'll be discussing today on our Moment Safety Podcast with walieyullah. We have many aspects of home safety. In our last episode, we discussed about electrical fires. We discussed about fire safety and how we can prevent fires and how we can know where fires can cause hazard to us, why fires can be risky, what can lead to fire in our homes, and how we can control them. And in case of emergency, what are those things to put in place? Today, we'll be talking about electrical hazard. And firstly, Mr. Bolaji, are you online, sir? Mr. Bolaji, kindly unmute yourself. Mr. Bolaji, are you there? Are you there,
I'm
Mr.
there.
Bolaji?
I'm there. I'm very much with you.
Okay, I think
I'm
Mr.
very much
Bolaji.
with you, Wali.
Okay, thank you very much for coming. Briefly introduce yourself to us, and our first question to you, sir, about electrical safety or electrical hazard in our homes. What are the major electrical hazards in our homes and in our community? It doesn't only stop in our homes. Like the boy that I said got electrocuted. He didn't get electrocuted in his home, but in the community, in the neighborhood, where the transformer was wrongly placed without protecting it. So now, can you tell us what are the major electrical hazards in our homes and in our immediate community? Please kindly discuss about this with us in the next few minutes. Let us start with that.
All right. Good evening, everyone. My name is Bolaji Ogunbumi, an HSE professional, and I first of all want to appreciate Walilia and the entire team that put this avenue together to be able to educate people on safety. So then I'll start with
Are you there, Mr. Bolaji?
the major electrical hazards that we have are at homes.
Please, we can hear
Hello,
you loud
can you
and
hear
clear.
me?
But we can hear you loud and clear, sir.
Hello. All right. So, one of the major electrical hazards we have at home is electrical. We overloading our electrical sockets. Most of the times, we observe that a lot of people don't have background knowledge of the ratings of the sockets compared with the cables or anything we plug in the outlet. So it's a major overloading of our electrical outlet is one of the major electrical hazard at home. And another very important one is um, when we have water around our electrical circuit. Then when we have also poor ratings of our circuit breakers at home, because when it comes to home, majority of people pay less attention to electrical safety. But in our industry, we take anything electrical installation very, very important because we know anything can happen as a result of that. And as a result of this little knowledge about connections, a lot of electricians that do all these connections at home, they don't pay attention to details. They don't even have background information of what are the facilities that will be installed at that particular home or house. So I guess with that, let me pause a bit as we roll and give other speakers other avenue to also speak. Thank you very much, Wali.
Yeah, thank you very much. That was very brief. Really appreciate that. Now, talking about these hazards, um, Engineer Gabriel, are you there, sir? Is Engineer Gabriel there?
Yes, I am here. I am here, Wali.
Engineer Gabriel, Mr. Gabriel, are you there? Mr. Samuel, are you there?
Waliu, I'm here.
Okay.
I'm here,
Yeah,
Waliu.
yeah, like Mr. Balaji rightly said about electrical hazards in our homes. He mentioned electrical
Yeah.
sockets and overloading of electrical sockets, and about the competency of those that install this our electrical connection. Does it mean that if we do not overload our electrical socket, for example, or we use competent persons, does it mean that that is where it ends and there can be no possibility of having electrical hazard or risk of getting electrical exposure that can lead to accident in our homes? Kindly elaborate on this in the next few minutes, sir.
Okay, good evening, everyone. My name is Samuel Gabriel by name. I'm an electrical technician and also HSE professional. I'm sincerely grateful for the opportunity given to me by Waliu to educate us and also learn from others. Well, for that, please, can you
We
hear
can
me?
hear you clearly, sir.
Okay, for that aspect that my colleague and brother just talked about, brother. The real fact is this: because of the way things are, especially in Nigeria and India, because of the cost of living and so many things, I would say not all about if the person is competent, which is the electrician or the engineer that giving the job. Like let's use for house wiring. But see, you can maybe somebody want to carry out an house wiring or a house wiring, and you say, okay, somebody come, an electrician to come and help him or her check and give a quotation. And when the electrician comes, which is a competent personnel comes and evaluate everything and say, okay, this, let's say for an example, a 3-bedroom flat is going to use 500,000 to wire the house and put all the necessary and the best quality materials to use for the house. And the person will say the price is too much just because the person don't have money. And the person will now look for a cheaper rate or a cheaper electrician that will come and help him or her to do the house wiring. Meanwhile, the person will now need to buy an fake cable, fake sockets, and fake electrical parts or electrical accessories to wire the house. Those things leads to fire outbreak. You hear so many fire accidents in the house, so many fire accidents in the market, shop, and all those things. Sometimes those things are caused by either a fridge plugged on an underrated cable, water heater plugged on an underrated cable, or a fake socket outlet, and even the overloading that you talked about. Those things are majorly the cause. Money, we say safety costs money. Many people don't have that money or don't have that knowledge to say that, okay, let us buy the original things. They always feel and think that all electrical materials are all the same, and meanwhile we have the fake ones which can lead to spark and can lead to fire outbreak and damage the whole property. Like I always say and I tell people, electrical materials at home is the most essential materials in the house. Even if you build the house and done everything, yes, you can't see the electrical fittings easily from the outside. You can see the paint, the building, and everything, the artwork. But any mistake from the electrician or any mistake from the materials can bring that house down in a twinkle of an eye. I want to give room for other people to still talk. I have so many things to say, but let us see here from other people. Thank you very much, Wali.
Thank you very much, Mr. Gabriel Samuel. Sometimes for your house, you go just see one or two connections. You go just put one or two things for your socket, and immediately your bulb is already showing signs, already getting low because you connected one small thing. These are necessarily the kind of signs that you know that the electrical connections in your home is very bad. Yes, safety is costly, but the cost of not being safe is expensive. From what Engineer Gabriel said, it shows that our connections is not only by the number of sockets or the number of connections that we have, but the rating or the requirement of each equipment or appliance that we are connecting. So it means that you can connect 10 phone chargers, for example, and it will not affect your cable or it will not affect your socket. But connecting but connecting like just two ions, for example, or one ion and one fridge in the same electrical socket can actually lead to an accident. It can actually lead to a fire. You can see signs of your cables overheating. These are the things that Mr. Gabriel has tried to enlighten us with. And he has also told us that it's not only about connection, it's about the quality of the cables that you are using and the quality of the socket, of the required rating that you are using for your installations. From there, we will be going straight to Mrs. Marian. Mrs. Marian, are you there with us, ma? Mrs. Marian, are you there with us?
I'm here. Yes, I'm here. Can you hear me?
Yeah, I can hear you loud and clear.
Okay.
Now, we want to talk about what happens after preventive measures. Okay, we've done this, we've put this in place, we've done this, we've done that. But it's possible for us to still have an accident. Like, we use the most competent electrician in our home, we use the required rating, we did this perfectly, but there's the possibility of still have an accident happen. One, like someone getting electrocuted or shocked or fire still occurs. Please, can you explain to us, to the listeners, on what to do if, so, for example, someone gets electrocuted and is being held by the electrocution? What is the next thing that the person or we that we are around to do? Because what we see commonly in our community is that if somebody to get electrocuted to maybe a socket or naked wire, we start using stick to hit the person's head, to hit the person's brain, to hit the person's leg. Is this right? And what are those things that we need to put in place when such thing still happens to us? Even if it does not electrocute the person, even if the person is safe, what are those things that we need to do to prevent the occurrence of that kind of incident?
Okay, thank you, Mr. Wali. I'd like to talk about electrocution, but mainly because most of the things that wrap around electrocution has to deal with first aid. And first aid is not something we want to do on audio, one. Two, is also something we not want to do in the absence of a competent person. I will talk about it, but I also want to list some other things that can happen as a result of electricity. I'm sorry, you might hear a dog barking. I'm sorry, please. Okay, so apart from electrocution, we can have burns, either direct or indirect burns from electricity. Exposure to electricity can cause that. So the direct burns can be as a result of the route of entry. So, for example, you hold a live wire and then the electricity decides to use your body, as your body is now the wire now. You know, normally electricity is supposed to pass through wire. So your body is now the wire through which the electric current flows through. So you can have burns as a result of that impact. The burns can be physical, it can also be internal. So what you do, most times when you have an exposure to electricity, is advised that no matter after all the first aid you do, you must go to the hospital, because you don't know if there's an internal bleeding or there's an internal burn. So that's that with burn. I'm trying to be brief. Then we also talk about fire. We've talked about fire sometime on this podcast, and we talked about the specific extinguishers to use when you have a fire. And we know in Nigeria, in the absence of those kind of extinguishers, you can make use of your sand and all that. And I know we stressed here on that day that we don't use water for electrical fires. We stress that so much. So whatever, depending on the magnitude of the fire, whatever you're using, you know that you would have alerted the fire service while trying to use the sand to quench it. Then we also have secondary effects. For example, you were standing on a ladder. Most times every man at home is a handyman. So this socket no dey work, this socket is doing this, is doing that. Somebody might just climb a stool or climb something. Now let me quickly fix it. So yes, you might get struck by, you might get like electric shock or something. So the fact that you are walking at height, the force of the electric current can make you fall down, which is now the secondary effect. So you had electric shock and then you also fell down. So that falling from that height is also a secondary effect. So that's just putting it briefly. Then, because while you mentioned something about somebody who got electrocuted to a transformer, I also want to talk about arcing. Electrical arcing is obviously not something that happens in our homes, but just for us to, because this is like a learning curve for all of us. Electrical arcing is something that happens when we have electrical currents passing. So most of these are electricity poles. Sometimes if you pass by electric poles, you'll be hearing all those, there's the kind of sound it makes. So electrical arcing is basically when electricity jumps, when there's an air gap, electricity jumps. And the distance it jumps depends on the voltage of electricity passing through the cables. So basically, there's nothing you can do about arcing. So it's just for you to try and stay away from such places, really. So, and then maybe when you're going house hunting, you can decide to stay away from houses that are situated or located around there, because in Nigeria here, we don't really have a, I mean, most of these things are not situated in non-residential areas. So you who's going to look for somewhere to live, if it's something that you can deal with, as in to stay away from such environments, yeah, it's advisable for you to stay away from where you have electrical poles and all that, NEPA poles. So basically, so electric shocks can have three outcomes. So yeah, somebody can go through like a mild electric shock. And yes, I want to address something that the host said. They say when electric shock somebody, you use stick and do. So basically, all those using stick, wear rubber slippers. Well, just trying to increase the resistance. In electricity, there's something called resistance. So I don't know how to explain it, but I'll try and do it in a layman's English. So, because I call electricity a necessary evil, it's something that we all need, but it's something that we cannot manage if it decides to just let loose. So, electricity is releasing itself, like the flow is coming, but there's something called a resistance, something that holds some of it back, like pulls some of it back so that it doesn't flow in all its glory. I don't know if it makes sense. So the resistance basically is something that prevents like the free flow of electricity. I don't know if I'm explaining this well, but that's what I can come up with in a layman context. So maybe the electrical guy here can make us explain better so that we can understand. Yeah. So basically, what the using stick, wearing rubber slippers, and all that, what we're trying to do is to increase the resistance of, as in increase the resistance works inversely to flow of electricity. So when the resistance is increased, the flow of electricity is less. So basically, we're trying to increase the resistance so that the flow of electricity through your body, that's you now who's trying to help the person who has been electrocuted, is you increase your resistance. So the flow of electricity through you will be less. And if the flow of electricity through you, and then of course, because you're trying to help somebody, you're not trying to go and hold the electricity, the exposure limit is also low. So that's the science behind all that. Yeah, so basically there are three outcomes when somebody is electrocuted. Like I said, when somebody goes through electric shock, this is like first thing. So is that the person is conscious? If the person is conscious, the first thing to do basically in all three outcomes is to try and put off the source of the electricity.
Please, we can't hear you clearly, Mrs. Marian.
Hello, can you hear me?
Yes, we can hear you now. Can you please round it up?
Okay,
Because
so what was the last thing you said? Okay, so there are three outcomes basically. So the first outcome is the person is conscious. What you do is you put off the source of the electricity, you call or you make some arrangement to take the person to the hospital, and then you run the route of entry. That's where the person touched the electricity through water. So if you have a running tap, you let it run until the pain is less, or if you don't have running water, you can open pure water and then just run the person's hand over it. If the person is conscious and breathing but not talking, you put the person in a recovery position and then you make arrangement to take the person to hospital. If the person is unconscious, you make arrangements to take the person to the hospital, but you perform CPR to ensure that the person gains consciousness before you proceed to
please,
take
what
the
is
person to the
CPR? To
hospital.
those who don't understand what CPR means, can you briefly explain what CPR means?
Cardiopulmonary resuscitation. CPR is
Okay.
cardiopulmonary resuscitation.
So we can Google more on that
So,
to know what that means in order to revive someone who is not conscious. Kindly continue, man.
no, I think we'll advise them to take a first aid class so
Okay,
that
I
they'll
think
be
that
well
would be good.
equipped.
Yes, very important. For every household, it's very important to have that basic training. because it can happen to anyone around us. Thank you very
Okay,
much,
yeah.
Mrs. Miriam, for that beautiful input. Right about now, we are still coming back to you to complete your discussion with us because you have a lot to give us today, and we are also ready to receive it. We are still going to call you back to round up your discussion. Right now, I have something that I need to point out because there are so many funny things that happen in our community, especially here in Nigeria. They will tell you that if you want to hold naked wire, just hold your breath. Don't breathe and just hold the wire. It will never shock you. It go shock you. You go see. It go shock you. By the time the thing shock you, it won't really shock you. See, but the time you say this thing no go shock me now. Now I'm shocked that the thing shocked me. All those things, they work for where we have 20 kilovolt, and we have 200 kilovolts. You have serious current passing through. You see naked wire, naked cable. Where they use connect light from one house to another. You want protection, can't hold your leg. Say if you hold your breath, the thing will go shock you. You'll be shocked by the time the thing shock you, and the shock will become two. Sometimes when I go through some street and I see their street lights, very beautiful. You will love it when you have street light in your community. But the sad thing that I've noticed in recent times is that the street lights, number one, they are mostly metallic. The street lights are made of conductible materials that can conduct electricity. And after that, you know the second thing? It is very close to the electrical poles and the electrical wires, the electrical cables that are used to connect light to our homes. And you'll be seeing the power cable, the power lines, and the street lights, the top, very close to where the power line is. And you'll be wondering, who was the engineer that designed this? Who were those that installed an electrical street light close to where power cable is? I've seen videos of people getting electrocuted with street lights. So because of that, I want us to talk about the community itself. There are so many hazardous things that happen in our community that has led to death. And I'll be talking about this, and I want Engineer Danzaki. Engineer Danzaki, are you there with us? Engineer Danzaki, are you there with us?
Yes, I'm there.
Engineer
I'm fine.
Danzaki, are you there?
I'm here.
Yes, please.
Yes, I'm here.
Talking about the community itself. How can the community, what are those electrical hazard that is in particular to the community? And what are those things that should be specifically put in place? Like I mentioned, the issue of electrocution of a boy with a transformer that got electrocuted to a transformer. I just mentioned another one that got shocked, that got electrocuted with the street lights. There are a lot of them like that. What are those things that can be used to prevent this? And how can we go forward with respect to electrical hazard in the community? Over to you,
Okay.
sir.
Thank you very much. My name is Saiki Daniel Ojo. I'm a health and safety professional. So when we talk about safety, what we actually mean is accident prevention. And then when we now talk about electrical safety, we are trying to lay emphasis on electrical accident prevention. And then when it now comes to our community, it is very essential that we all should know that electricity is very hazardous. So there are two major hazards known to electricity. One, we have the electrical shock, that's shock hazard, and we have the thermal heat. So we want us to know that when shock occur, shock simply means that when electric current flows through human body. The voltage does not kill, it is the current that kills. Most times when some of us have stayed it's under power line, you'll be hearing that heavy sound. So that means that those things are transferred at high voltages to prevent energy losses. So in our community, so it is very essential that we put appropriate laws in place to deter people from getting close to where we have high voltage electric cables like the power lines. Then two again, where we have transformers, it should be well barricaded with a safety sign. Danger, do not go there. But what we should be expecting from our government is to
It's like we have lost it to Engineer Danzaki. Please kindly signify when you come back. Kindly signify if you can hear me clearly. Engineer Danzaki, are you there? I think Engineer Danzaki has gone to rest. He has gone to sleep. My engineer here is thinking that I'm in rest in the other way. No, not that kind of rest. I think he's going to call back. I think it will be reasonable for us to continue this episode while we wait for Engineer Dansaki. And we'll be going straight to Mr. Emmanuel. Most of those things that we are discussing, lots and lots of people do not know that we have issues around safety, issues that concern the kind of exposures we have to electrical hazard, how it affects us. Some people don't understand when we talk about electrical pumps and how it affects the internal organ itself. I've seen someone get electrocuted and we could see the smoke coming from his ears. Yes. So all these things are the kind of things we need to discuss here. I really appreciate everyone who has decided to contribute. And going to Mr. Emmanuel. Mr. Emmanuel, are you there? Can you signify?
Yes, I can hear you loud and clear.
Yes, thank you for coming. Mr. Emmanuel, we've been talking about electrical hazard. Those that know about itself does not know how to prevent themselves from it and how to reduce the risk. Mr. Emmanuel, is it possible to have electrical hazard and danger it possesses from happening in the first place? Is it possible to have electrical hazards and this danger that is possessed, that is the risk from happening in the first place? Can we prevent it from even happening in the first place? That okay, we don't. So anything that has to do with electricity or the hazard, it won't happen. Is it possible for us to be able to prevent it in the first place?
Yes, thank you, Mr. Wali. Hazards are preventable actually. When you look at it from the safety perspective, um, for you to put hazard into consideration is because you are looking for a way to prevent them. So yes, as safety professionals, we all believe accidents are preventable. Now, coming to this hazards, what are the hazards itself? Even a human being is a hazard. Somebody that is close to you is a hazard. The children at home, they are also hazards. They are exposed to this electricity. So once you are coming in contact with this electricity, which already is a hazard on its own, like Mrs. Marian said, is a necessary demon. It's something that you just must use, and there are hazards already present in it. So what we are looking at is, are these hazards preventable? Yes, they are preventable. They are very, very preventable when you look at them. Now, going to some of the points that were raised, like he said about overloading of electrical sockets and cables. You see that they also spoke of ratings when it comes to the issue of overloading of electrical sockets. Sometimes what we just do, we just get anything from the market, like Mr. Gabriel said. we get substandard product due to want to save cost. I want to save cost. I remember when I was entering into my house, it was an old house. I had to change the whole electrical wiring. I did them. I went to the market. I went there. I got the ones I needed that I knew that were top notch for what I wanted to use it for. But in some cases, because we want to save costs, we try to use substandard product, and when we see the effect, we start complaining. Now, also, Mr. Bolaji talked about water along electrical circuit. Water and electricity, we know they are friends. They are like five and six. So once you
We
are
can hear you. Can you
using
continue? We can hear
electricity,
you very
you
clearly.
have to. Yes. All right. So once you are using electricity, or once you are working with electricity, you have to ensure that your hands are not wet. Neither is the area where you are working wet. Even as little as changing the light bulb. If you want to change the light bulb, you say, "Let me quickly change it," and your hands are wet. You want to quickly change it, and you quickly get electrocuted. Uh, that's some of the reasons that that's the truth about accident, because it's the point. Let me quickly, I want to, let me make I do am sharply. E no go take time, and before you know, e no go take time for the thing to shock you. Even touching the socket of this electrical socket, you have to try and ensure that your hands are not wet. For our extension cords, overloading of them, we also have to look out for the plugs, our power cables. Some of our power cables, they may be frayed, peeled cables. Sometimes we even use our hand make our join am. Oh, so you see some connections and you're like, what if this thing go bad? And a typical Nigerian man will tell you, "Oga, I don dey use am like this since." But one thing we fail to understand is that these machines, when they want to spoil, they don't tell you. I've seen an instance where a machine that was working normally, and in fact, from what the technician was telling me, he said they ran the machine throughout the night. It was supposed to serve the next morning, and the next morning it shut down when they needed it. That's machine for you. So we have, as humans, if a machine that you have programmed that it should work at this rate is shutting down, how much more we as humans that we tend to do something and maybe sometimes we forget, the machine itself can fail. So the best thing we can do on our part is ensure our own safety, and ensure that while working with these things, we put our safety first, so that even if the electricity itself wants to, even if there's a defect in what we are working with, we on our part will be safe. Let me not go too details, because other people will still talk, and I believe we'll still come back to round up the discussion. Thank you very much, Mr. Wale.
Thank you very much, Mr. Emmanuel. Engineer Danzaki, can you hear me loud and clear?
And I can.
Yeah,
I
please
can hear
kindly
you.
continue your discussion. Please kindly continue your discussion.
Okay, I'm very sorry for the last time I actually had network issue. So what I'm actually saying the last time is government must begin to enforce all their laws. People must not build houses under where high voltage cables are passing, because we can see all that around us. And then two again, where we have places like transformers, people should make sure that they don't build shops, or those places must be well barricaded with block and then barbed wires. So such places should be protected against unwarranted entrances. And then two again, safety signs should be put in those places. Then two again, based on the hazard, I will also like to lay more emphasis on why we don't use use water to fight electrical fire. Hello, can you hear me? Hello, hello, can you hear me?
We can hear you loud and clear. We can hear you
Hello.
loud and clear.
Okay, good. So why we don't use water or foam to fight electrical fire is that fire can tend to have some charges stored in it, and because panel has component like capacitor that's help to store charges. So when you now use fire, so it can cause possible electrocution, arc or spark. So this is one of the vital reason why using water to fight fire, sorry, to fight electrical fire is not accepted. So and based on the question you asked me that way forward, I guess I've answered it that okay, government should begin to enforce those laws, making sure that in our community people don't build houses or set up structures close to where we have high voltage electrical cables, and then where we have transformers to prevent what is happened to the small boy you spoke about, to barricade such places and then put warning signs there to deter people from going to such dangerous place. Thank you.
Wow, that was beautiful and specific. Thank you, Engineer Dansaki, for this enlightening moment. Mrs. Marian, are you there? Can you hear me clearly, Mrs. Marian?
Yes, I can hear you, Wali.
Mrs. Marian, are you there with us?
I'm here. I can hear you. Can you hear me?
Yes. We are discussing about what to do after getting electrocuted or shocked by electricity. Can you kindly? I knew that you had so many things to say, so you have the floor, ma, to give us more of your safety dose.
Okay, so I talked about electric shock basically. So I said there are three possible outcomes, and the three possible outcomes are all linked to first aid. And because as safety professionals, we don't encourage you to go, like I mentioned CPR during the last discussion. It's not something we advise people to go and watch on YouTube and then just carry out. You understand? We'll advise that you get your first aid training so that you'll be skilled on how to carry out CPR. You even know what CPR is. If you have a first aid box at home, depending on the type, there are some first aid boxes that come with a defibrillator. So if you have a defibrillator, you really don't need to, like all those of us that watch American film, those things that people used to shock people back to life, something like that. So if you have like a defibrillator in your first aid box, you know I've worked somewhere before that we had a defibrillator in the first aid box we had in the organization. So yes, but we need a trained first aid person to do that, because I mean, carrying out CPR on somebody who doesn't need it, somebody who's conscious, that will be counterproductive. And if we have burns, depending on the type of burns, the burns too will be treated like every first aid treatment. So whether it is direct or indirect, the treatment for burns too will be as first aid, as you've been taught as a first aider. Then for fire as well, you also need to be a trained firefighter or a trained fire warden, depending on whatever you choose to call it, for you to know how to fight electrical fire, the type of fire extinguisher to use, basically what to do, and then when to throw in the bucket or throw in the towel and know that, ah man, this fire don't pass me, or I cannot, like it is bigger than me. I won't be able to fight it. It's best for me to just leave it and then call the fire service. And then in the case of secondary effects, what exactly are we dealing with? So if it's just like a light electric shock, because sometimes the shock may not be severe, but somebody who's standing on a ladder and somebody who's standing on a level ground, who feels the same impact of shock. Okay, let me explain. Like sometimes if you're living in an apartment that is not airted, I believe we all know what airting is. You might touch something and you feel a slight electric shock. It might not be serious. Or sometimes there are some electrical appliances that you have, and for some reason you touch the fridge and you just, this fridge they shock. Oh, there's a slight shock feeling you get. So imagine somebody who's standing at height, who feels that shock. That's slight startling you get might make you fall from height. So if you fall from height, depending on the effect of the fall and the height from which you fell from, will now determine what exactly you are treating. So in this case, you're not just treating electrical fire. Sorry, you're not just treating the cause of the electricity. You are treating the fact that you fell from height. So whether it's a sprain or a strain or a bruise or whatever it is, or a puncture, maybe there was something on the floor and maybe it pierced you or whatever. So the effect of the electricity or of what you feel determines what you actually treat. So in the case of electrical shock, I've talked about the three possible outcomes. If it's a burn, you know what to do. If it's a fire, you treat the fire depending on how big, if you can manage the fire. And then if it's secondary effects, you treat the secondary effects depending on what exactly it is. Sometimes people feel some shocks that kind of violent shock that throws you from the source of the electric current to the wall. So maybe in that instance, you hit your back on the wall or you hit your head on the wall, and then so you treat the effect of that impact as opposed to electricity. Yeah. So basically, that's a summary of what I was talking about.
Thank you very much, Mrs. Marian, always giving us the dose as usual. And now we'll be going to the end of the discussion. And the duty placed upon me is to summarize all that has been discussed. But before I continue, I would like to seek the permission of all the speakers. If I may I, my lords, kindly put in the comment, if I may I heave, if I may I, my lord. Oh, my lord, may I give the summary of all that have been discussed today. Can I may? If I may I may? Yes, I've been getting that you may I may, you may if you may. Thank you, Miss Lovett. He said you may if you may. So that is another. So if I may, thank you for giving me the opportunity to summarize these things that have been discussed today. Strictly speaking, electricity is one of those things that we need to take care of in our homes. These days, we are very careless of electricity, especially to our kids. Our kids are born, the kids of today, they are born naturally to understand the kind of current world that we live in. Immediately they bring light, they will be the one to take all your electrical appliance, your touch, your phone, everything. They will be the one to plug everything without asking them to. They will even go and plug the fridge. They will go and on the fridge because you switched up the fridge before. If you give them the opportunity, they can even change the current. They can even change the fuse if the current is low. So these children of nowadays need to be monitored and need to be supervised when it comes to electricity. There are so many things that our professionals have spoken about. Mrs. Marian discussed so many things. Mr. Bolaji gave us specifics, and he also highlighted what are those things that are related to accidents, electrical accidents. Mr. Grebe gave us very technical illustration. Mr. Emmanuel elaborated the whole thing, and Engineer Dansaki gave us the community view and how we can prevent accidents. To cut the whole story short, part of those things that I highlighted is from Mrs. Marian. She spoke about ethylene, which is also very important. Most of us, we have low quality ethylene in our homes, and sometimes when you touch the wall, you are electrocuted. And don't get it twisted. Sometimes when we have low ions in our body system, any little thing will shock us. Any small thing will shock us. Even ordinary charger will shock you. Because even ordinary battery where they buy 20 naira battery, all those lead ion battery will even shock you. Because you have low ion in your body. But that doesn't mean that because you have high ions, you go and touch pole light. That one will shock you. It will shock you when the thing shock you. But then we need to make sure that our home is properly heated. If you are renting an apartment, a new apartment, make sure that you check that apartment is properly heated. It's very important. Another aspect is when you have low ethylene, when there's a thunder strike, it tends to give more effect to us. Another thing I would like to talk about is use of signages and preventive measures, engineering measures. When you change your fuse in your house, some of us will be looking at the other street. That street light is high, our own is low. Let us go and change it. Your children are looking at you. Don't think they are not looking at you. The day they want to take share and do it themselves, that's when you know that you need to put guard. Anywhere you are changing your fuse, you are changing your connection, that you have your electrical connections, please always make sure that you build a kind of guard that prevents easy access to that platform. Your generators also, they are also a form of electrical hazard. Let's try to manage them specifically. You need to control how we access our generators. Even when it comes to issue of fire, I've seen situations whereby a generator was working but there was no light inside, and they thought that maybe it was a little connection, maybe the connection got loose, but it was still working for some minutes, but there was no light inside. But they were like, maybe someone tripped or maybe a cable tripped, not knowing that the generator was burning seriously, and it was burning inside the generator house where there was petrol. So when we see that our generator is working but it's switched off, we should go immediately to go and know what is happening. It's very important for us so that we will not have an issue of electrical fire. Then we talk about appliances. Your appliances is very important. Mr. Bolaji gave an illustration here, his comment here. He said many electrocutions are home fires, and home fires can be prevented simply by understanding basic electrical safety principles and adhering to safe practices. Very correct. When you are using your iron, for example, or your electric cooker, or as Mrs. Marian said, your fridge, and you are receiving electrical shock, mild or serious electrical shock, is a sign that there is something wrong with your appliance, and it means that you should go and repair them. Now, to repair, we will manage until you start managing to spend money on the effect of the accident. Then you now say this country with the manage, no money. Meanwhile, the little money you should have used to prevent the accident, you fail to spend that money. At the end of the day, you are spending more money to correct the effect of the accident. Repair your equipment, repair your appliance, repair your toaster. Now, when I say toaster, I don't mean the person that is toasting you. I mean your toaster. Toaster. You know what I mean by toaster now? I know, excuse my neck. Repair your refrigerator. You are receiving shock. Repair it. Don't manage it. Repair your cooker. Repair your irons. And at the end of the day, if there's fire, don't pour water on your electrical fire. Mrs. Marian mentioned this. By the time you have fire that is coming from electricity, don't say you want to use fire to switch it off. You will receive shock. It will shock you when you get the shock. Now, double shocking, you go double pattern shock. About the talk and say double shock, which I receive. So when you have electrical fire, is not the right thing to do to put water. The first thing you need to do is to switch off the source of where that current is coming from. Remove the fuse in your house. If the fire is coming from the fuse, then that is where the major issue is, because it means that you have the disconnect from the pole. But before that time, the best thing you can ever do is to have a fire extinguisher in your home. That is the best thing that can ever happen, is to have a fire extinguisher in your home, because that is what will prevent the accident from happening. Sorry, that is what will reduce the effect of the fire, and you extinguish it immediately. These little things that we are talking about are very essential. Sometimes electrical fires are mostly caused in our homes, are mostly caused by overloading, or when there is high current or high voltage. I think either current or voltage. Where there is high voltage, we know that it has been communicated here that it's the current that kills. Voltage does not kill. But when you have a high voltage, there is possibility of having a fire. So it's very essential that in your home you tend to manage these things. I think I've seen something here: improper tagging out of electrical power during maintenance or repairs. Also very important for us to know this. So it's very essential to know these little things so that in case we even have fire, we will know how to manage the fire. And I think this is when we will be ending our discussion for today. But before we close it out for today, I believe we have learned one or two things. We have learned one or two things when it comes to the issue of fire safety in our homes and our community. Next 2 weeks we'll be having another beautiful discussion, and we are planning on another episode of home safety. We want to focus more on home safety this time around, and we'll be focusing more on things that has to do with hazards that we are exposed to when it comes to our home. And in our next episode, we'll be discussing, God willing, if our speaker is going to come, we'll be discussing about food poisoning. That's another part too, because me, I like food though. And I don't want somebody to come directly or indirectly or based on my own negligence, I will not poison myself. Exactly those people that used to make fufu in our community. You see the way they make the fufu and amala. They go dey sweat inside the fufu. Thank God that the fufu dey hot sef. Abi the amala dey hot when they dey do am. If na cold food we dey chop, we don't chop poison. Yeah, Mr. Bolaji said adding lototo should be strictly adhered to. Lototo means log out, tag out, try out. That is when you are carrying out a repair, like you want to change your electrical connection or you want to change your bulb, for example. You lock out, that is, you log out. It means that you switch off the source of the electricity and you make sure that nobody is there, and you put a tag to indicate that do not switch on. That is the tag out. Then try out means that you test to show that there is no residual current inside the electrical connection. Poor socket and plug rating specification, very important. When you are doing your electrical installation, your plug, your socket, the ratings must be specific to the kind of power, electrical power or electrical connection or rating that you want. You can't use the same socket that you are using to charge your phone to power your refrigerator. Not be the same thing. And your fuse too must be properly in position. And those are the things that we need to check. Also, we need to check for residual current. Yes, Mrs. Lovett is saying that food is very important. Oh, yes, food is very important. That is why we'll be discussing about food next 2 weeks. Mrs. Lovett said she can't wait to experience this. Thank you. Very soon, in 2 weeks' time, we'll be discussing about food, and we want you to also invite others to participate in this beautiful discussion. Yes, Mr. Emmanuel said use of competent personnel. Don't go and hire one electrician in your street because it is cheaper, and maybe you just finished learning electrician for 3 months, and you say, let me quickly use this boy so that we do the connection, or more you are on your own. When the issue happens, the money you go spend, you go pass the money that you are supposed to use to engage a competent person. Mr. Danzaki also said trip hazard from extension cord. Also very important. Some of us will connect our cables wrongly. And it can cause people to trip on it and fall. And also we connect it along doors. Doors goes and come, and the movement of the doors can actually cause them to get exposed. And when they are exposed, there's possibility of having a faulty connection or a difference in connection at the socket point, and at that it can lead to fire accident. So let us make sure that we properly install our extension cord in our homes. Residual current is also very important. Thank you, Mrs. Marian, Mr. Danzaki. Mr. Emmanuel also said avoid carelessness while working with electricity. Don't be doing electrical work, installation, and you are careless, and you are also listening to Kokonu Wero, and you are distracted. Nigeria is not good, Nigeria is this, and you are doing electrical connection. It will shock you when the thing shock you. And Mr. Ban Bodare, thank you for coming, sir. He asked a question: is Lotto applicable in home electrical safety? During repairs, some people tend to do some simple electrical connection themselves. Imagine someone that maybe he believes that there's no light, maybe they just switch off the lights, maybe they just take off the light, and it's like, let me quickly change this thing, let me quickly do this thing before they bring light. And he has forgotten that that connection was switched on, and they bring on light. Now, there might be lockout based on the fact that there's no current. But what if they now bring, in fact, no lockout safe, there's no even lockout, because the power is from the source and they have not switched off the light. So it's possible for there to bring that at any time while in position, and at that point in time is in direct contact with the conductor that can cause the electrical shock. So electrical joining of wires also very important. Some people join the electrical cables randomly as they wish. Yes, usually, to be sincere, our fathers used to do our fathers, because those men are actually hardworking. They always want to engage themselves, and they use this wire to join this wire, to join that wire, to join that wire, to join that wire, to join that wire. At the end of the day, you will be having issues with your electrical hazard. Then Mr. Dasaki is also saying here that bypassing the safety measures in electrical fuse. Yes, we know that lockout, tagout is LOTO. And Mr. Bolaji also included LOTOTO, which the last TO means try out. That is to check and to confirm that there's no residual current. Yes, log out and tag out. That is that about today's discussion. Thank you all for making up to this session. Thank you all for joining us. On our next episode, most likely we'll be talking about food, like I mentioned, and we'll be inviting a food expert, a food safety expert, to join us in this beautiful discussion. We'll be inviting, I won't want to disclose the name now, but he's a food expert, a trainer, and he understands what food safety is all about. And to kindly correct, we should know that our LOTO is lock out, tag out. It is lock out, tag out, lock out. That is, you are locking out, preventing the current from coming in. That is the last source of current from coming in, and tagging it out by giving a sign to indicate that someone is working on it. Thank you. We are all here to learn together. We are all here to improve. We are all here to know about safety, so that we'll be more cautious in our homes and we'll be living in the safer climate of the world. Thank you all for coming. I can continue to exhaust the name that I'm seeing here. Mr. Bambodari, Mr. Dansaki, Mr. Emmanuel, Mrs. Marian, Mrs. Lovette, Mr. Mustafa, Mr. Emmanuel, Mr. Bolaji, and every other person that has taken their time to join us. Mr. Gabriel, I'm seeing Financial Avengers. Thank you for coming. We really appreciate your presence. Thank you for making it up with us. Remember to always share our link to invite others. Remember, we can have a greater number next time. We had the maximum of 12 participants. I know we could have had more. 12 participants. We have people joining us on various platforms from various links that we've sent. Let's always try to send this link to others so that we can always learn together, and we can also always promote the safety world. Thank you for joining us. We have a YouTube channel that we discuss about safety issues. We have our safety videos. Always remember to share our safety videos when you see them. We shall post this too for learning purpose to those who didn't make it to this session, so that they can also learn at every point in time. Remember to always share our videos. You can visit us at Safety World on YouTube and subscribe to our YouTube channel. Just type Safety World, and you will see us live on YouTube channel. And remember to subscribe and switch on the notification button, so that you will always get alert when we drop a new video. Thank you for coming. See you all next time. I remain your wonderful host, Walieyullah, and bye-bye, and enjoy the rest of the day. See you all next time.